So optimization problems are a rich source of application problems for us. So let's spend some time and do a couple applications. Now in this example, we want to know what point on the plane x plus y plus 4z is equal to 8 is closest to the origin. Okay, so we want to minimize the distance from a point x, y, z that is on this plane right here to the origin. All right. Well, it would help if we remembered the formula for distance. So let's look at distance, shall we? Distance is equal to the square root of x minus x0 squared plus y minus y0 squared plus z minus z0 squared. We talked about this in one of the very first sections of this course. It's kind of an expansion of the same one we learned in algebra and geometry class a long time ago. Okay, so for our purposes, x0, y0, z0 is right here. x0, y0, z0, which is going to make this real easy because there's 0, 0, 0. So for our purposes, distance is equal to the square root of x squared plus y squared plus z squared. Now, we could work with that. But looking ahead, we're going to have to take a lot of derivatives. And this is going to be pretty brutal with all the square roots in there. So we want to use a little bit of logic. And this is a trick we use a lot. We used it in Calc 1 and we're going to use it again. So I'm going to call capital D equal to the distance squared, which takes the square root of x squared plus y squared plus z squared and squares it. So it becomes just x squared plus y squared plus z squared, and it doesn't have that square root in it anymore. Now, the logic of this is that, note, minimizing that new capital D also minimizes lowercase d. But capital D is easier. Well, let me put it here. Capital D is easier to work with. All right, so this is a very important little piece of logic. We will use this little trick many, many times, right? So because the distance is the shortest distance between 2 points. It's a Pythagorean theorem thing, right? So it's the square root of x squared plus y squared plus z squared. But that would also work for the distance squared, right? Because if this is a positive number and then you square it, if it's as small as it can be, then the square will also be the smallest it can be. All right, so that is what we're going to work with. That's going to be our function. We're going to use capital cursive D. All right, so let's find our critical points. Critical points. All right, so we need capital D sub x, or excuse me, we have one other problem, which is we have too many variables. So we need to make one other note. So one note is that working with this is easier. But the other note is we have too many variables. We only know how to do 2 variables. So second note, note number 2, we need to eliminate one of the variables. Right? We can only have 2 variables. We cannot have x, y, and z. For our method, we need 2 variables. All right, well, before I do that, so let's go back up here and so look at it. If I wanted to eliminate one of my variables, right, in my function d right here, d is the x squared plus y squared plus z squared, too many variables. So if I solved this for, say, x, right, I could take that value, right, bring it over and all that stuff, and I could get what x is on its own. Or if you will, I could subtract the y and subtract the 4z. So note that it's part of the same note. All right, x is equal to 8, take away y, take away 4z. So that would mean that d is, instead of x squared, it's 8 minus y minus 4z squared plus y squared plus z squared. Now I have two variables, and now I'm ready to go. Unfortunately, the only variables I have are y and z, which I'm not used to, but that's okay. We can do this. So let's find the critical points. All right, so I need d sub x. Oh, d sub y. I don't have an x variable. D sub y. All right, I'd bring the 2 down. So 2 times 8 minus y minus 4z to the 1 power times the derivative of the interior, which is negative 1, plus 2y. Just kind of putting this together. That's negative 16. That's a 2y and another 2y, so that's 4y. And that's a minus 8z times a minus 1, so plus 8z and minus 16. Just simplifying it. It's not strictly required, but it'll make things easier. All right, so that's d sub x. Now remember, we're going to set that equal to 0, and we're going to come up with some answers. All right, now d sub x is equal to, I keep saying x, d sub z. We don't have an x. D sub z would be, back up here to d, bring the 2 down, 8 minus y minus 4z to the 1 times the derivative of the interior, which is negative 4, plus a 2z. Again, combining like terms and kind of bringing things together, we have an 4 times a 4 times a 2. So that's 16 times 2, so that's 32. 32 plus 2 makes 34z. Minus 8y times a minus 1, so plus 8y, minus 64. All right, these have to be equal to 0 simultaneously. And the easiest way to do that is just to solve it in Maple. So I told Maple, hey, I have this equation set equal to 0 and this equation set equal to 0. And I put them in curly braces because I wanted to solve it simultaneously, comma, for both y, comma, z. So I put those in curly braces. And when I do that, it tells me that y is 4/9 and z is 16/9. And then to figure out the x, I just plugged back in to my function, 8 minus y minus 4z, and I put back in those values that I had. Okay, so let's write all that down. All right, there we have it. So y is equal to 4/9, z is equal to 16/9. Maple gave me those. And then technically Maple gave me this other one, but I could have found it as well. So there's my critical point. So my critical point is 4/9, comma, 4/9, comma, 16/9. That's the critical point. It's the only one. There is no other one. Okay, so let's run the test. To do the test, we're going to need dx, yy. I keep doing xx, but we don't have x in this one. I gotta stop doing that. All right, yy, dzz, and dyz, because those are the only variables we have. And of course, you can only have two variables. So, all right, so dyy, dy is right here, right there. So there's dy, simplified out. And of course, you can use Maple to help yourself simplify it too. So the derivative of that with respect to y is 4, which is nice and easy. Dzz would be 34. Dyz would be 8. So putting this together, d equals dyy times dzz minus dyz squared, which is 4 times 34 minus 8 squared. It worked out to be all constants. So this is a positive number. That's all I really care about, right? It's positive. So it's positive. Well, if it's positive, we have to check dyy. Dyy is also positive. And if they're both positive, that means that the critical point, CP critical point, 4 ninths, 4 ninths, 16 ninths, is a minimum, right? Is the minimum. Just like we thought it would be, distance to the origin. Let's look at the graph. All right, so I have the plane right here, and the point that's closest to that origin, the origin being down there, is this point right here. 4 ninths, 4 ninths, 16 ninths. It's the closest that plane ever comes to the origin. And there we go.